So I'm gonna start talking about rigid bodies. So first thing first, let me load one of those objects. First thing first, a tip for optimized working within Houdini environment is that if you have two monitors, not now because you are looking at Zoom and one of your monitors is engaged, but when you're working on your own, you can add a floating node. So you see that it's pretty much this. I usually open this and move it to the other window and close this one using that clicking on that little triangle, close this one, and on the other window I see that one. And if I add a node, you might want to see, oh, where are my properties? Just press P. Whenever you need them, press P, they load up. Here I can do that as well. I just like open it back. I can, instead of like having two parts, because I want a large place for my node trees, so I just click on this little triangle, close that one, and from now on I press P whenever I need parameters. P stands for parameters. So I add a geometry, I call it like object, my object. Oops, what was that? And I get inside, I bring in one of those file geometries that we have. I want to use the same project that we had. I go here, set project, I set it to job. You see that it's already there. I set it there, so it could be it's already set. So if I didn't know it was not, so I go there and just select it and say accept. So then when I go to open and I press job, it jumps into the oh, I should have get into sample project. So go set project, inside sample project, accept. From now on, when I press open and job, it gets into that. I'm gonna bring in one of those geometries here. Press P, load one of those geometries. Maybe the first one. So I press P again just to turn that off. This geometry is massive, so large. So I want to add a transform node. Make it smaller, so press P, make it smaller. You see that why my changes doesn't show, because my visibility, the blue flag is on the file, not on the transform. So I want to see the transform being shown. I move to that. So sometimes you want the transform, so the visibility would be on this, but the another node would be kind of like templated, kind of like shown in a faint way, so you would be able to compare. So you can turn on the purple flag on one of them. So you see that the purple is on, so I kind of see the first one and I can compare what is happening. So I turn off the purple for now. And if you want to deactivate a node, there's yellow flag. You say, oh, hey, don't do anything. You turn it off. You deactivate it, or you bypass it, as Houdini says. But there's another very important flag, and this is I, or middle click. Middle click on that, and I'm going to talk about that. Give me a few seconds to set it up. I'm going to make it like 1/10. Press spacebar F to frame it. Move it back slightly, so it's in the center. Okay, so that's good for now. You see that this object, so a good technical director, a good visual effects artist always see how many resources getting involved, how much of the memory and CPU is being used. So you middle click on any node, you see that, okay, 10 megabyte is used for only this object. And how many, so this object has 100,000 points and 200,000 primitives, or 200,000 polygons and 600,000 vertices. So just imagine that you want to make loads of these. So loads of these objects are supposed to fall one after another. So there should be like an army of statues, like hundreds of them. So after transform, I add a node called copy and transform. And I press P here, and you see that it creates a second copy. Total number of copies 2, and you can copy and move. So I move it in which direction? Z direction. Blue is Z. So I move here that much, maybe 15. So, but now I have like 1.2 million vertices. If I create like 100 objects, my computer starts to die. So how we can have that and not end up, so like how many objects do I have now? I've got like 20 million polygons and 60 million vertices. And how much of memory is getting occupied is around 2 gigabytes. 1.5 gigabyte of memory is being occupied. How we can deal with that? There's a nice technique, I delete that one. There's a nice technique which is called pack. So you pack all of your information into one single point. So before packing your object, I go back, so like, let's have it here. So before packing your object, you see that you can select different pieces of your object. So like this object is full of points and dots, and you can select them, you can work with them. But I'm gonna go, I don't want to do an editing, so just go back to our web. So, but now I press tab and add a pack node. Pack node packs your object into an instance. Just I middle click on it, you see that, oh, it's just 1 point now. It's one primitive, one vertex, one packed geometry. How much of memory is occupied? 7 kilobytes. And so it's basically, it draws a ghost version of what you have, but it's a functioning ghost version. It can be broken, it can be multiplied. So let's do what we did, like copy and transform. And this one, I'm gonna, what was that, 15? Yes. So like, let's say 100. You see, it suddenly creates that without any hesitation. And I can navigate easily inside the scene. How much of memory is occupied? It's just 55 kilobytes. It's impossible. So what about 1,000 objects? Wow, it's there. It's achievable. So like, and how much of memory? It's less than a megabyte. It's just magical. So packing your geometry is a and they also can work for you. So like, let's go back to like 500 one. So let's move. So this is why, Callum, you'd have to do it procedurally. So you see that I just want to do a bit of movement on the whole thing. So you see that because the transformation node is added as a separate node, so I can just select that one and just here I just can change the translation on that one, and you see that everything gets updated based on that. So you can simply create a, so let's move on to the next topic, which is like we packed them. We have 100 statues. I'm gonna release them. I'm gonna drop them on the ground. So I start creating a DOP network. So I have my sub. So let me tell you something. I'm gonna open Photoshop and draw something for you to explain these things. Houdini is a combination of is a collection of like working levels. So I already have done that for the previous class. So you see in Houdini that you have like sub or materials, sub or objects, or materials, or ROP or render operators, output. So these are different levels. So let's say I'm going to create a DOP or dynamic operations. So a DOP network is another environment somewhere. So let's say it's this time like red. Dynamic is red. So this is another like level, another environment that your object. So like you see like you create a combination of nodes that they do simulation for you, rigid. So let's call this DOP, DOP network. And your surface operators, they come and interact with these nodes. So at surface level, the object is created. We wanted to create this amount, an array of 100 statues. So let's get into the dynamic operator, so which is a DOP network. We get into that. You see, there's nothing inside that. You can say, hey, go and read that those objects. I call it RBD pack object. So RBD pack object, I press P, says that so it says that go and find my objects and turn them into rigid body dynamic objects, RBD. Where are those objects? So they are here inside this object node. A good habit is always add a label at the end of each tree. So here I add a null node. Null which means nothing. There's nothing in this. It's just basically a label here. Add a null node here. I call it like out geo, so geometry output, and I connect it to here. So from now on, if I do anything in the middle, so the last output node is that one. So it makes my life a lot easier. So inside dynamic operator, inside RBD pack objects, I press P and I say that where is your SOP? So SOP means surface operators or objects. Where is that? You point it to that out geo. So it gets loaded, but nothing happens because you need a. So you see, if I play, they don't fall. You need a rigid body solver. So you call a rigid body solver. So in Houdini, for anything, you need a thinking algorithm, or in another word, a solver. I attach it here, and I play. They fall, but there's no. So they don't fall because there's no gravity. So you can simply add a gravity force. And you see that if I hover on the node tree, it just snaps and gets in the middle. They fall, but they pass the ground. So why I see both of them? Because The selection is on the gravity, but it can be on the oh no, because the objects are visible yet. So I'm going to turn on the visibility of the objects, because we loaded them back into the RBD pack. They pass through the ground because there's no ground. So here you add a ground plane, and you merge the ground plane with the gravity node. So the ground plane is there. One thing that helps you, so makes life easier, it says that the left input, this one, affect right input, this one. But we can say they mutually affect each other. So now these objects fall and they all interact with floor. And you see they are different objects. They have different animations. So how I can make it more dramatic? So this is what I said, that it's good to have an output, because I want to add a transform node here in the middle to transform all of them together like that. But you see that because the output is being fed into dot network, so this one starts to simulate them. So you see that even though they are like multiple different objects, you see 100 objects are falling and they are behaving differently. Let's make it more dramatic. I am rotating it right away like that. I just want them to fall on top of each other. Minus 90, and I'm moving it up. So let's see. Let's go into dynamics, play it. So 100 objects are falling on each other and interacting. It can be 1,000 objects. So, and it's so fast, see? The simulation is done so fast.
So
yes.
How did you rotate them like that?
Okay, good question. So you see that I created, so let's go back to the first file. I transformed that to this. I'm gonna turn this off. And then I packed it. I packed it because I wanted to be, this would be very light. So one single point would be calculated instead of like 2 million points. Then I copied. Then this is, then I added another transform node. That transform node grabbed all of them together and rotated them. So there's another transform after like multiplication. So and then it's been fed into the dynamic. Okay. Can I go crazier? Yes, I am. So, what I can I want to break one of them. So like I get into the object. We want to break apart, shatter this one. So I'm gonna hide the dynamic one and I turn this on. I'm gonna shatter apart. Let's start from. Well, let's work on this one. I'm gonna shatter this statue into pieces. So this is how we do it. You have seen that we have a shatter node in the model here. You select your geometry, and you select, you create on the shatter, and it shatters it into pieces. But we're gonna create it, and I'm gonna explain it how it works. We're gonna create it on. So we have a algorithm. It's called Voronoi. This Voronoi algorithm, it uses your geometry. So you see that every node that you generate, it's a good habit to hover on the input and output and see what it needs. So here you see that it needs a geometry, and it needs a bunch of points. So it grabs your geometry, and based on a bunch of points, it cracks your geometry. So I'm gonna create those points. So I press tab, and I use a. So if I use a scatter quickly converts your geometry into a bunch of points. So you see that if I click, so this is one of those times. I'm gonna click on the scatter to just see the scatter. So a lot of points is generated, nice. But you will see that these points are only on the surface. You can see that? They're not inside the object. But I want to break this object from inside. So, so what I do, I turn my object into a cloud using ISO offset. So using ISO offset, it turns into cloud. You see? A cloud has inside as well. It's not a surface anymore. And then feed that into scatter. Now you see that the points are inside the object as well. So I don't need that many points. So maybe like 20 pieces. And now I can feed that into Voronoi. So let's see the result. The Voronoi shatters my object apart using those points. So how I can figure out that it is working? So you see that there are a lot of lines around it, but you can use an exploded view. This exploded view is just a viewing object, so it's not. You can even click on like template that one in. So I press P. So this is for viewing only. You can use it for animation, but it's just for most of the time it's just for viewing. So I can see that like, okay, so these are the pieces that has been generated out of that Voronoi fracture. Now what you can do, you can so let me middle click on that. I have 200,000 polygons out of that. So it's basically the same amount of polygons that has been. So I don't want to use exploded view anymore. We know how it works. So we have 200,000 polygons. So I'm gonna pack it before breaking it apart. So you can use a pack geometry. So this is what would happen. I pack it, and it turns into a one packed geometry. But what would happen is, if I go back to the dynamic, they fall, but you can see that they are cracked. You can see that they are shattered. Can you see the cracked lines? But when they fall on the ground, they don't break apart because they are packed into one single point and not like fragments or pieces. I go back to the object. Instead of pack, I use something else called assemble. And inside assemble, I say that create pack geometry. And if I middle click on that, you can see that now I have instead of one here, one pack geometry. Here I have 31 fragments. So it's 31 objects now. Oh, I hope I don't get Houdini to be killed. Let's wait. Oh, there we are. I'm gonna save it. Oh, I didn't save it. So I'm gonna call it rigid body simulation. So let's hide my own original objects. Come here. So it does the starts to do simulation. I'm gonna lower down the number of objects. Just I think I managed to kill Houdini. Okay, I'm gonna lower down the number of copies. Oh, what is that? Is it 100? Let's start from 10. So 10 is more manageable. Let's see if it works fine with 10 geometries. We don't know. These like pieces, let's see, yeah, you see that they start to disintegrate early on. Let's see if they break apart. I don't know. I hope they do. Yes, they do. So, but they start too early to break apart. Just look at the ones. See this one? So you have to glue them together. So it's not too complicated. It's very complicated if you wanted to write down the notes. The glue. So I go back. So you can select your objects, and you can click on this rigid body and glue adjacent. So like these pieces. So especially you can select like this copy node transform after after assemble here. You select that and you glue it together. I don't do it because I just okay. So a very important question that one person asked. It's end of 9-hour teaching, so sometimes I quickly switch back to Persian when so when you see some words like very vague word in the middle of my talking, they're not English. Just realize myself that sometimes my brain doesn't function properly. so I'm gonna how I can constantly read them without problem. So you have to create a cache on disk. So what you can do, you can so you see that this last node in the dot network is basically a cache node. It says, do you want to cache this dynamic? Are you happy to convert it into a cache file on the disk? So you can cache the whole sequence, or just right click here and then channels and remove that, and or simply hold Control Shift and click, and just like say let's cache like 50 frames of it on disk. So when you save to disk, it starts rendering it into the disk. Where about it saves it? It goes to the so you see that it has sent to sim folder. So the sim folder has it. So later on you can read it back. So I can add a file note here and read that simulation back. So you see that this file note is set to read. Then now I can swap to file read node. So from now on, let me see if I can. Am I reading it? Oh, let's say that it's a sequence instead. Yes. You see that I can easily click within those 50 frames. I just cached it for 50 frames. I can, and the color of the timeline is not blue. When it's blue, it means that Houdini has done some calculations and is thinking, and that thinking is being baked or cooked, as it uses the terminology. But when it is orange, it means that it's not thinking. It's referring to a written file on hard disk, and it loads it back again and reuses it. So you see that. That's why you see that it's simulating here, but is reading here. So when it comes for rendering, so let's say you are happy with that and you want to render that out. You go to the out. And here you add I press P. You add a mantra node, and this mantra node is basically, so here is basically another workspace, and this workspace, like all of those operators and stuff, they travel into that mantra node and gets rendered over there. Yeah. So this mantra is like, it works much more solid and much more stable now, because it doesn't need, Houdini doesn't need to process the simulation for every frame and render it out. It just looks at the cache file and just render it out. So that speeds up the simulation. Okay, that's for now.